Katarzyna ma troszeczkę więcej czasu niż pozostałe osoby, ale wiem, że nie więcej niż 12 minut, prawda?
I tak będę się...
Dobrze. Oddajemy głos pani Katarzynie.
Okay, welcome everybody. I would like to thank you for giving me the opportunity to be with you here today. My name is Katarzyna Druszkiewicz and I am representing TIF North Poland company, which is a notified body designated to carry out conformity assessment procedures for medical devices. And today I will talk about key issues related to certification of medical devices utilizing artificial intelligence. At the very beginning, I would like to introduce some basics related to medical devices. Every manufacturer, before introducing their medical device on the European Union market, must demonstrate the compliance with all applicable requirements outlined in the medical device regulation. This is crucial to ensure that the medical device meet the necessary quality and safety standards, which helps to protect patient safety and maintain the integrity of the healthcare system. In the case of higher risk class from 2A to class 3 devices, a notified body is involved in the conformity assessment procedures, and the outcome of its assessment determines whether the device can be CE marked and placed on the market. So we are an independent institution designated by Polish competent authority to assess whether the legal requirements have been fulfilled. And when we're talking about medical devices utilizing AI, we can distinguish between three types. First is a software as a medical device, which may be independent by having its own medical intended purpose and claimed clinical benefit. The example was presented yesterday by Raygenix company, and it was an AI image analysis of CT scans. And another type of software considered as a medical device is a software in medical device. This software driving or influencing the use of a medical device and also has a medical purpose and claimed clinical benefit related to driving or influencing a medical device for a medical purpose. For example, automatic infusion pump. AI software can monitor patient parameters like blood pressure or heart rate and adjust the rate of medication administration. And another story is third type of software is a software driving or influencing the use of medical device which doesn't have or perform medical purpose on its own. And this software can be considered as a medical device accessory. All of these softwares are in the scope of medical device regulation, but have different requirements to fulfill. So we should take a look at the specific medical purposes and the definition of medical device software, which is defined in Medical Device Regulation 2017-745. And the medical device software is the software that is intended to be used alone or in combination for a specific medical purpose, regardless of whether the software is independent or driving or influencing the use of a device. So what the specific medical purposes is defined in MDR. It could be diagnosis, prevention, monitoring, prediction, prognosis, treatment, or elevation of disease. Or, for example, diagnosis, monitoring, treatment, elevation of, or compensation for an injury or disability. So the intended purpose is essential because it determines whether our product is a medical device or does it or it isn't. The intended purpose as described by the manufacturer of the device is also relevant for the qualification and classification of software. Here we have famous Rule 11 from the MDR, which is applicable to medical device softwares. And it says that software intended to provide information which is used to take decisions with diagnosis or therapeutic purposes is classified as Class 2A, except if such decisions have an impact that may cause death or an irreversible deterioration of a person's state of health, in which case it is in Class 3, which is the highest one, a serious deterioration of a person's state of health or a surgical intervention, in which case it is classified as Class 2B. What is important here? That it is enough that it may cause death or serious harm without a probability analysis to raise the risk class. And if we have Class 3 devices, which is the highest one, this means that additional requirements must be met. For example, conducting a clinical investigation. In these cases, we see that the lowest risk class of softwares, which are intended to make a decision with diagnostics, it's at least Class 2A, which involved the notified body to the compliance process, which including auditing of quality management system and assessment of the technical and clinical documentation. What is the legal framework of the requirements for medical device software? The Regulation 2017-745 Annex 1 states that for devices that incorporate software or for software that are devices in themselves, the software shall be developed and manufactured in accordance with the state of the art, taking into account the principles of development lifecycle, risk management, including information security, verification, and validation. And what is important, that every stage should be well documented. And I can say that the most important in this documentation is the risk analysis and risk management system. It should be carefully aligned with and reflected in the clinical evaluation for the device, including the clinical risk to be addressed as part of clinical investigations, clinical evaluation, and post-market clinical follow-up. And I would like to focus on the clinical evaluation, which is probably the most challenges for software manufacturer. The intended medical purpose shall be supported by clinical evidence which results pertaining to a device of a sufficient amount and quality to allow a qualified assessment of whether the device is safe and achieves the intended clinical benefit when used as intended by the manufacturer. The software manufacturer shall specify and justify the level of clinical evidence in three key components. The first one is valid clinical association, which showing association between the output of the algorithm and the targeted clinical condition. And this association should be clinically accepted or well-founded, which means accepted by the broad medical community and or described in scientific literature. What the challenge I see here is that the treatment guidelines may vary between European Union countries, and this aspect should be considered by manufacturer. Second component of the clinical evaluation is technical performance. Evidence supporting technical performance can be generated through verification and validation activities, for example, unit level integration and system testing, or by generating new evidence through use of curated databases, curated registries, reference databases, or use of previously collected patient data. The challenge here is how to avoid bias of the datasets. In some cases, validation is sufficient, but there are also cases where a clinical trial will be necessary to give clinical performance evidence. And clinical performance evidence should demonstrate that medical device software has been tested for the intended use, target population, use condition, operating and use environment, and with all intended user group. So, what is a frequently asked question from medical device software manufacturer is it necessary to conduct a clinical investigation for my product? To answer this question, manufacturer should ask himself a couple more questions. What is the risk classes? Because in case of class 3 devices, clinical evaluation should include data from a clinical investigation, with some exceptions described in the MDR. Another question is there sufficient data available? In cases where data is available, a retrospective analysis can be performed. In cases where data doesn't represent the variability of input parameters for the clinical performance of the algorithm, the missing data could be generated in a prospective clinical investigation, which required positive opinion of bioethics committee and should be submitted to competent authority. There is one more question, because maybe our software demonstration of his conformity based on clinical data is not deemed appropriate. The justification must be based on the output of the risk management, and this should include an evaluation of clinical state of the art, including alternative diagnostic and treatment options, including those identified from literature, and an appraisal of their relevance to the device under evaluation. So, there are many challenges for manufacturers of medical device software's AI that should be addressed. I have discussed only a small part of them. And what you should remember is that all medical devices need to demonstrate adequate performance in relationship to safety and effectiveness for their intended use. Certification process is very complex. In average, it takes about 1 year since application to receiving certificate. A regulatory expects everything to be documented. If something is not documented, there is no evidence to evaluate. So documentation is essential. Thank you very much for your attention, and I wish you good luck with your poster session.
Thank you for your very interesting presentation. So next one, we move on for the poster presentation. I counted 32 speakers. Each one of them has 2.5 minutes. So keep the time limit. And I would like to invite the firstly, Ania Taratuta. I give you the voice.
Thank you. Hello, my name is Anna Taratuta, and I would like to share with you my recent research about the selected properties of tantalum-based coating for nickel-titanium alloy for cardiovascular implants. Various types of heart defects can be treated by devices called occluders. However, the use of nickel-titanium alloy, despite its good biocompatibility, is associated with the risk of allergies, blood clots, and problems with hypertrophy. To reduce these negative effects, I proposed modifying the surface by adding a thin layer of tantalum oxide by atomic layer deposition method. I used two precursors, tantalum etoxide and water, applied layer by layer, and I measured the chemical composition by XPS. The nanometric thickness of the coating was measured by spectral ellipsometry, and adhesion coating to the substrate was measured by scratch test method. Cytotoxicity was described was described by cell visibility on fibroblasts. The chemical composition of the coating was 30% of tantalum and almost 70% of oxygen. The adhesion of the layer was really good, and the thickness of the layer was 14 nanometers. Physiochemical studies was complemented by biological tests, and the results of the cytotoxicity showed a beneficial effect of the coating for tested material. It can be concluded that the thin layer of tantalum oxide has the potential to improve the properties of the material used for cardiovascular implants, even with the complex shapes. Thank you.
Thank you. Next person, Aleksandra Mikulikowa.
And next person, Julia Oskroba. Yeah?
Hello, my name is Aleksandra Mikulikowa, and I would like to introduce you to the topic of my study, which is applications of 3D printing in pediatric rehabilitation products. The purpose of my study was to review the current state of knowledge and also to analyze the market examples of 3D printed products designed for children with temporary or permanent disabilities. And in this study, I focused mostly on rapid prototyping and rapid manufacturing techniques, such as 3D printing, 3D scanning, and also computer-aided design, which are implemented in the whole designing process of rehabilitation products. And during the market analysis, I have found several products which are 3D printed, such as orthopedic insoles, cranial remolding helmets, hand and leg orthosis and splints, and others. And very important thing in this study was to show the influence of 3D printing to the whole designing process, and there is a noticeable trend on the market to shorten the designing process time. So the whole process begins with a 3D scanning of the specific body part, and then based on the 3D scan, the whole virtual model of rehabilitation product is designed and customized, and then manufactured by 3D printing techniques, such as fused deposition modeling, and also by multi-jet fusion. And another interesting thing is the market prediction that 1 in 3 customized products will be 3D printed by 2027. And to sum up, the 3D printing had a significant influence on the healthcare technology sector and enables the designers to design products which are lightweighting, which are customized, and also worldwide available. And what is very important, it shortened the whole time of designing process, and also enable to design products which are child-friendly designed.
Okay, thank you. Julia Oskroba, next person, Barbara Rynkus.
Good morning. My name is Julia Oskroba, and I'm honored to stand here and share with you a part of my scientific work, which is assessment of wear of temporary photopolymer crowns in a chewing simulator, created in cooperation with Dr. Anna Ziembowicz and Dr. Wojciech Kaiser. The aim of the study was to create a photopolymer temporary crown using CAD/CAM and 3D printing technology, and to examine this dental prosthesis in conditions that imitate the environment of the oral cavity in a period of 6 months. The research was implemented using thermocycler and chewing simulator, and the results were shown based on physicochemical properties, but also aesthetics, which is so important when it comes to dental restorations. The material used in a study is light cure resin, sensitive to UV spectrum, and it was manufactured using digital light processing technology. Samples were artificially aged using a thermocycler, where they were subjected to rapid temperature changes in the range of 50 degrees Celsius. So it simulated the events in oral cavity, like drinking tea, coffee, or cold beverages, or eating ice cream. Then the samples in the initial states and those artificially aged were subjected to chewing simulator, where they were, it was a mechanical degradation of the surface of the samples immersed in the artificial saliva. The bar graph shows the result of physicochemical properties measurements after thermal treatment. Significant change was the most seen in the flexural strength, which decreased by almost half after this thermal treating and temperature changes. Microscopic observations made after chewing simulator showed several cracks and chips on the surface, but only on the samples subjected to the degradation of 6 months. Those subjected to it for 3 months were not significantly damaged. The samples were also soaked in red wine and coffee as a part of discoloration test, which this material failed, and as you can see on the screen, they undergone major color changes. Summarizing the research, the tested material and final prosthesis fulfill its role as a temporary restoration, but for the period of use no longer than 3 months. But it is totally sufficient for the patient, which is awaiting his final long-term prosthesis. Thank you for your time and thank you for your patience.
Szymon Sieciński, next person Katarzyna Kolbuch. Barbara Rynkus, sorry. And next Szymon Sieciński, yes. Okay.
Okay. Good afternoon, ladies and gentlemen. My name is Barbara Rynkus, and today I would like to present recent results of my work. The aim of this work was to carry out a preliminary study on the surface modification of magnesium alloy by applying aluminum oxide coating using the ALD method. The electrochemical properties of the substrate and the modified alloy were investigated to study the effect of the applied coating on the biodegradation process. The material used for this study was commercial WE43 alloy, which contains elements such as magnesium, yttrium, rare earth elements, and zirconium in its composition. The samples of bare alloy and with the coating applied were tested in their initial state and after 4 and 8 weeks of immersion in PBS solutions. Microscopic observation, electrochemical studies, and hydrogen evolution tests were performed. The results of the hydrogen evolution test showed that the coating reduces the amount of hydrogen release most effectively in the first 3 days after immersion, but over time this value begins to approach to the results obtained by the uncoated specimens. Microscopic observations showed a large number of surface cracks, which suggesting the penetration of the solution into the surface, into the substrate, and development of the degradation process. This is confirmed by the potential dynamic and EIS results, which showed that after 4 weeks, the coating did not provide proper corrosion protection. It can be seen in figure 6 that the curves for the samples with and without coating overlap. Based on the collected results, the following conclusions were drawn. The proposed coating affected the degradation of the alloy, and after 4 weeks in immersion in the solution, a similar mechanism of the degradation obtained. And after 8 weeks of the immersion, the coated samples showed accelerated degradation of the process, which was related to the dissolution of the layer formed due to the attachment of chemical compounds from the PBS solution and elements present in both the substrate and from the coating. Thank you very much.
Thank you. Now Szymon Sieciński, after Katarzyna Kolbuch.
Hello everyone, my name is Szymon Sieciński, and in today's talk I present the classification of the heartbeats in electrocardiograms with the k nearest neighbors, algorithm random forest and support vector machines. The aim was to compare the performance of 3 different methods for heartbeat type classification in the ECG signal from the well-known MIT BIH arrhythmia database with 3 aforementioned methods. The dataset consisted of 11 recordings. However, the dataset we analyzed 11 recordings. However, the dataset is larger and contains half-hour to channel recordings of ECG signals. The features were based on the ECG signals, such as the amplitude of each wave's intervals between the waves QRS complex. We used min-max normalization, then SMOTACE, that's the method for interpolating the class sample, the minority class samples to address the imbalance between the classes, and feeding KNN, random forest, and support vector machine. The slide presents the performance of the classification of SVM. Due to time and space constraints, I don't present the other classifiers, but the table on the right side presents the overall accuracy, and we've achieved the state-of-the-art performance even on the limited set of signals from a publicly available database. However, the number of signals is small, the number of heartbeats is obviously small, and the features were manually calculated. However, this is the task for future studies. Thank you for your attention.
Thank you. Katarzyna Kolbuch. And next one, Joanna Kruszyńska-Szwedo.
Hello everyone, my name is Katarzyna Kolbuch and I'm grateful to be here today. This work was created with assistance of Dr. Wojciech Kaiser. Thank you. The topic of today's presentation is the creation of a prototype personalized relaxation splint used for bruxism. Bruxism is increasingly considered to be a disease civilization caused by time pressure and stress. It consists of excessive activity, especially at night, of a stomatognatic system characterized by grinding and clenching of teeth. The use of splints is necessary to avoid consequences such as tooth loss, cracked enamel, or headaches. Today I would like to show you how to create a prototype splint using laser scanning and additive technology with different variation in occlusal splints thickness for one patient. Okay, as you can see, the first step was to obtain a finished gypsum model of the patient's jaw and mandible and have it laser scanned with a handheld scanner due to not having an intraocular scanner. The next step was to develop the scanned model in mesh mixer software used to develop triangle meshes. This is not a specialized dental software, but it proved to be sufficient. You can see the design of the prototypes in the middle two photos. A model resin was then chosen to create the prototype splints so that in the event of failure there would be little cost involved. Using digital light processing technology, the splints were printed. Surface treatment was the last important step to guarantee the best possible surface quality and therefore patient comfort. Now I would like to move on to the conclusion. Applying the prototype splints to the gypsum model showed a satisfactory fit and no movement relative to the mandibular teeth, regardless of thickness, 0.75 millimeters and 2 millimeters. The thickness of the splint can be selected according to the intensity of the patient bruxism. It is an individual problem. During the printing process, the splint had to be placed with the teeth against the supports to achieve the best possible fit to the patient's palate. The use of modern technology is much faster and more precise compared to traditional manual manufacture of relaxation splint. Thank you for your attention.
Thank you. Joanna Kruszyńska-Szwedo, and the next person, Ewelina Sobotnicka.
Good afternoon, ladies and gentlemen. The purpose of today's speech is to present the research I conducted among 15 children with autism spectrum disorders, including Asperger's syndrome. They were aged between 7 and 11 years and participate in group violin lessons conducted according to my therapeutic method based on the Suzuki method. The main concept of the Suzuki method is that every child has talent. Although this method is practiced worldwide, it is rarely used by autistic individuals. To determine which values of this method are crucial for including children on the spectrum, I distributed my own survey questionnaires to teachers and parents in Poland, Australia, and Italy. According to the World Health Organization, autism occurs in 1 out of every 100 children. A significant percentage of these children also experience mental disorders such as depression, which can be attributed to social and communication challenges and a patterned and restricted repertoire of behaviors. Moreover, the lack of development of divergent thinking and a creative attitude can further reinforce their rigid thinking, resulting in limited communication with other children. Therefore, to prevent them from experiencing social isolation, I have developed a therapeutic method. An important component of the 9 months experiment involved group instrument lessons, during which children learn to play musical pieces by ear. It is worth noting that autistic individuals may possess perfect pitch, which facilitates their ability to play musical instruments. The therapeutic program led to an improvement in the level of divergent thinking, creativity, communication, and social skills among the children. This was evident in the creation of new musical variations on music theme, their acceptance of other participants, and their mutual listening to musical pieces. The results obtained are presented in the chart below, where 0 represents autism and 1 represents Asperger's syndrome. Thanks to the therapy employed, it's possible to initiate early prevention efforts in selected developmental areas among children with non-neurotypical characteristics. Thank you for your attention.
Thank you. Ewelina Sobotnicka, and next Katarzyna Czop.
Good morning. My name is Ewelina Sobotnicka. I represent Łukasiewicz Research Network, Krakow Institute of Technology. I would like to present work which aim of the study was a review of carotid artery blood flow measurement method, especially ultrasound method, which we can use for measurement in extreme condition or during various type of activity. Sorry, this is not my. Oh yes. Thank you. We search PubMed database and we find 1904 publication. From this 1904 publication, we choose only 5 which describe devices using for measurement carotid artery blood flow method and which was used after testing measurement in extreme extreme condition, mainly in orthostatic test. Interesting solution was a device developed by Kenny and Wong. They developed novel wearable patch which can be placed on the neck. Conclusion for this work was carotid Doppler ultrasound has great potential for measurement in extreme condition, and the most promising solution are wireless wearable patch. Thank you very much.
Thank you. Katarzyna Czop, and next Marta Kieliam-Rosik.
Good evening, my name is Katarzyna Czop and I am from Mickiewicz High School in Katowice, and in collaboration with the Silesian University of Technology we have created a foot-operated computer mouse. Our goal was to create an affordable way of accessing technology for individuals with upper limb disabilities. Commercially available mice are very hard to access in the Polish market and are usually very expensive. So we started with a 3D model. After testing, once we were happy, we moved on to 3D printing the buttons with PLA filament, and we used plywood for the main body because of its eco-friendliness and durability. The result was a very, very customizable mouse that the buttons can be adjusted in the 3D program, but if you want a quick switch, you can just turn the upper plate around. I can show you how the mouse looks like. You can turn the upper plate around to accommodate left-footed people. It is very also comfortable, and the cursor speed can be adjusted. The mouse was tested by a disabled person and has gotten positive reviews. We have also gotten new opportunities and experience, and we hope to expand, improve, and reach more people in the future. We plan on creating a world of technology where everyone can use it without limitations. Thank you for your time.
Thank you, Marta Kieliam-Rosik, and next Sara Saraj.
Good morning, my name is Marta Kieliam-Rosik, and I want to present result of influence of zinc oxide coating parameters by nano PVD method on physicochemical properties of magnesium alloy. Magnesium alloy could use to produce implants because of degradation in body fluid properties, and in this work I want to show you preliminary research to access the influence of the parameters on of applying the zinc oxide layer using nano PVD method on magnesium alloy substrate. To find a result of this research, a scratch test, potential dynamic test, and observation on scanning microscope was performed to the analysis. The material in this research was magnesium alloy AZ31 The chemical composition of the analyzed alloy was consistent with the standard recommendation, and the observation were made in scanning microscope before and after the corrosion tests. Potential dynamic tests were performed, and the last test was the adhesion test using a scratch test. After the research, the test showed that the samples with zinc oxide coating were characterized by better corrosion resistance compared to sample in the initial state. On the EDS analysis showed a lot of cracks on the surface layer on the zinc oxide, and occurs selective corrosion on the surface. And for the further tests, I want to conduct electrochemical impedance spectroscopy and thickness and hardness of the coatings. Thank you.
Thank you. Sara Saraj, and next Mirella Urzeniczok.
Good morning, everyone. I'll be presenting you the work of my team regarding the identification of the human body physical model, and it was intended for the exoskeleton designing. So we picked an industry that was we were curious about, which is the automotive industry. And in different positions, 5 to be exact, we modeled the physical model, the body physical model based on these positions. And that's because these workers work in very extreme conditions while holding loads up to 18 or 19 kilograms in a prolonged period of time, and that may cause a very serious illness and injuries. Here you can see my colleague doing the 2 of the extreme positions while holding loads and while not. And based on these positions and from the results of the goniometer, we obtained the physical model. And plus using the body part center of masses, we completed the whole physical model. And to validate this model, we conducted an analysis of the distribution of foot pressure. And that's because we needed to make sure that the physical body, human body, we obtained as close as to the real conditions. And here you can see the results. The first diagram, as you can see, presents, let's say, the theoretical measurements. And because we wanted to, like I've said before, to make it as let's say, as real and as close to the factual situation, we optimized these results, and we did it by conducting 2 methods, searching for global extremes using non-linear and linear methods. And as you can see in the table below, we have the results that are as close to the physical conditions of the colleague that presented these positions. And on the right, you can see the results of the joint reactions, and as well you can see the positions. And these positions, like I've said at the beginning, were selected based on the work of this person in the automotive industry. And these results will help us to develop the exoskeleton that will mainly be used to take off the load of the person that, like I've said at the beginning, is doing in such extreme positions for a, let's say, prolonged time. So it's not very healthy. That's it. Thank you.
Thank you. Mirela Urzeniczok, and next Ilona Karpiel.
Good afternoon. My name is Mirela Urzeniczok. I work at Łukasiewicz Research Network, Krakow Institute of Technology, and I am also a PhD student at Silesian University of Technology. The topic of my presentation is impedance cardiography better tool than ECG in supporting the diagnosis of the patients with the heart failure? The purpose of this study was to present a novel approach to support the diagnosis of heart failure based on the evaluation of the hemodynamic parameters using impedance cardiography in association with ECG, which is the standard for diagnosing this disease. In diagnosing the patients with the heart failure, the abnormalities in the electrocardiogram, such as left ventricular hypertrophy, evidence of previous myocardial infarction or arrhythmias, may indicate the heart failure. However, those abnormalities may also be associated with other disease. But by combining the ECG with measuring of the hemodynamic parameters by impedance cardiography, we may detect those abnormalities more accurate, and it can increase the certainty of the diagnosis and the survival rate of the patients in the long term. Thank you very much.
Thank you. Ilona Karpiel, and next Anna Tamulewicz.
Hello everybody, my name is Ilona Karpiel and I'm working in Łukasiewicz Research Network, Krakow Institute of Technology. The aim of this study is to check whether the respiratory parameters monitoring system, which includes a specially designed aesthetic belt worn on the chest together with a mobile application, can significantly help improve the efficiency of exercise. And as a part of the grant, a belt has been designed to monitor breathing, and its original application was to monitor the breathing of patients with respiratory disease, chronic obstructive pulmonary disease or asthma under conditions of normal life activity. A mobile device app has been developed to monitor breathing, which is becoming an attractive tool in the hands of more than just doctors. Apart from the application specifically dedicated to patients, we've started looking for another target group. The preliminary study included training on 2 treadmills, classic treadmill and vacuum treadmill. This is present in the future. The training involved one heavy person for whom a pace of 5 km per hour and 9 km per hour was set. Feature to show is the recorded portion of the respiratory waveform signal. The obtained signal allows to verify the minimum signal value, which corresponds to the person's intake of air, known as inspiration, and the maximum signal, which allows to verify when exhalation has started. And the results obtained are summarized in the table 1. The table shows the value of the average and maximum respiratory rate over time of the recorded respiratory wave signals on the vacuum and classical treadmill. In relation to the vacuum treadmill, an increase in respiratory rate and amplitude can be observed. And the respiratory rate during walking at 5 km per hour on a vacuum treadmill is around 30% higher than the respiratory rate on a classic treadmill. The respiratory rate during walking on a negative pressure treadmill is lower by around 1% than during running at 9 km per hour. And a short conclusion, it seems that the tool in the form of a belt application installed on a smartphone and a monitoring center is attractive to athletes who can be monitored by their personal trainer or specialist doctor. Future research will verify to what extent the received signals constitute or may constitute a material for verifying the efficiency of the activity data. Thank you very much.
Thank you. Anna Tamulewicz, and next Marek Czerw.
Hello, the topic of my presentation is the analysis of bipolar disorder genomic data to identify differences in gene expression. The main focus of this study is the problem of correct diagnosis of bipolar disorder based on differences in gene expression, which is present in peripheral blood leukocytes. The work was aimed at finding biomarkers that could facilitate the process of diagnosing bipolar disorder. For this purpose, data obtained from Affymetrix microarrays were analyzed. Data on gene expression in 29 patients with bipolar disorder and 25 people from the control group were used. In the picture, we can see the flowchart of the algorithm, which includes the pre-processing of data, then some simple statistical analysis, which includes two-sample t-test and false discovery rate estimation, which led to finding significant genes. And those genes were used in two research scenarios. First research scenario was the classification using two methods, support vector machine and linear discriminant analysis. The second scenario was the clustering method, clustering using two methods, hierarchical clustering and k-means clustering. A total of 8 genes with different expression profiles between the bipolar disorder group and the control group were found. Most of the identified genes have been linked to bipolar disorder in literature sources. Clustering led to dividing data into two clusters. In the first cluster obtained by the hierarchical clustering method, 60% of samples were control group samples, and the second cluster consisted of 83% of the bipolar disorder group samples. Similar but slightly worse results were observed using k-means clustering. Classification using the linear discriminant analysis method led to correct classification of 57 bipolar disorder group samples and 70% of control group samples. And the second method used, support vector machine, led to correct classification of 87% of bipolar disorder group samples, but only about 18% of the second group. Comparing the methods used, it can be concluded that the clustering methods turned out to be more suitable for the analyzed case than the classification methods. Thank you very much.
Thank you. Marek Czerw, and next Paweł Kostka.
Hello, hello everybody. My name is Marek Czerw, and I would like to quickly present research that is being carried out at Łukasiewicz, Krakow Institute of Technology, especially Biomedical Engineering Center, as a part of my implementation doctorate. The aim of the study is to check whether the development Textronic telemedical cardiac surveillance system based on ECG and respiratory rate can significantly contribute to improving the efficiency of hybrid cardiac rehabilitations. The research has produced a system including patient-fitted variable garment equipped with printed electrical connection network connected to electronic signal acquisition and wireless transmission module. This module provides fully autonomous operation and patient surveillance performed by a system at early warning levels would not require the involvement of a medical specialist. Also, we want our product to be competitive because of the low energy technology and materials we used to make the Textronic T-shirt in particular comfortable to use and wear. And the result, last picture shows the application that presents the synchronized ECG signals and wave respiratory recorded using a Textronic shield with dry electrodes, which allows for undisturbed measurement of parameters such as heart rate and respiratory rate, such important during cardiac rehabilitation. Thank you.
Thank you. Paweł Kostka, and next Emilia Skwarek.
Thank you, Mr. Chairman. Dear ladies and gentlemen, the main goal of the presentation created as a, in fact, report of 3 big projects we conducted in our previous cathedra, supervised by Professor Evarist Kacz, is some kind of analysis, yes, whether the initial state of separate signal processing before we put data into AI systems is still valid, is still alive. Of course, for me it's obvious that yes. And first conclusion on the first slide, of course it depends on the signal which we analyze, yes. So you know probably students where we are lucky after digital signal processing exams and subjects, yes, or before, more lucky, less lucky, that I think DSP is still a powerful tool. Because if we put like in deep learning raw data to abstract structure, yes, of the neural networks, we do not manage the adequate features of real processes, yes, and these abstract parameters created during learning process of the AI systems, just weights and biases of neural network. So, short travel through our 3 projects where we gathered, so designed both hardware, sophisticated hardware using the modern chips, so-called system on chip. So on small chip, we've got, for example, a whole ECG amplifier, yes, or another channel for PPG measurement, or like in a 3rd project, smart, I think, hardware developed by Professor Komorowski, Professor Mirek-Czak, also here. And really low-level programmers and electronics, also whole team. So you can see, for example, the powerfulness of the cascade filtering and other smart trick DSP methods. From raw data, there is nothing. Yes, from the first view, only noise. We can extract the signal below, a useful signal in the project where we tried, and we did it, to design the system to measure and to evaluate the cardiac output based only on the ECG measurement and impedance. There is also Dr. Alexander Sobotnicki and his PhD thesis. So, of course, we work not only in the world on this topic, but it's well-known formula since let's say 1970, and then then of course now we only adjust parameters to do a little bit better. Yes. Okay, so our projects develop also hardware and software were proved with this project with companies because we designed and developed really final products verified in clinical usage. Thank you. Have a good time.
Thank you. Emilia Skwarek, and next person, Bartłomiej Sawaryn.
Good afternoon, ladies and gentlemen. Today I'm excited to share with you the key findings of our research on car drivers' distractions and how we can use technology to enhance road safety. Okay, so as we all know, car accidents are caused by human errors are tragically common all around the world. In 2022 alone, there were over 21,000 traffic accidents in Poland, with a staggering 90.9% of those were attributed to human errors. Our study wanted to aim this problem by exploring the potential of classifying disturbances during driving using smart glasses, which were equipped with sensors. These sensors allowed us to collect a lot of valuable data while participants were driving in a car simulator. Our goal was clear. Can we identify and classify those distractions? So now let's dive deeper into our experiment. Each of 8 dedicated volunteers participated in different driving scenarios. These scenarios range from a baseline measurement to different scenarios like driving while drinking water, after consuming glucose, with using a phone, and even under the influence. Not to worry, no alcohol was involved. We used alco goggles, which simulated drunk person's vision. And each of these runs allowed us to better understand how different distractions affect our skills and concentration while we are driving a car. Our data collection process involved a few really important steps: data alignment, normalization, standardization, and also isoline removal. But the real star of our analysis was using random forest classifier, a powerful machine learning tool that can handle complex classification tasks. Here you can, at the bottom of the slide, you can see our driving simulator, as well as example of our collected data before and after processing. Now let's discuss the impact of our findings. We all know how distracting factors can really significantly impact drivers' focus during their journey. And what's truly exciting that our classifier did exceptionally well, allowing us to accurately classify different distractions. In essence, we've shown that combining 3 decision algorithms with the analysis of the EOG, electroencephalography signal, we have a potent tool for identifying distractions while driving a car. This research may have a major impact on increasing road safety. Thank you very much for your attention. I hope our research inspires you for further exploration in this critical field. Thank you very much.
Thank you. Bartłomiej Sawaryn, and next person, Dobrochna Fritz.
Yep. Hello, everyone. You are not sleeping, and that's all right. Let me just tell you a few words about my research, which was the part of my PhD, and it will be a new concept of the device of the acoustic emission analysis of human joints. Our goal was to create the device very useful for diagnosis of a human joint, of the condition of them, and we would like to our device to be very portable, very useful, and very cheap to be done. And for this purpose, we have used the emission of joints, which they were producing during their movements. For our device, we need to choose some parts, and the most important ones was the all right, this red one, it is the sound card, and the second one, the purple one, is the microphones. Of course, we just need the power supply and some cables to join all the parts together. As a result, we have created our medical device. And what was the most important thing is that we have 3 channels. So we have 3 points of acquisition of our signal, which is very important because no one else ever done this before. So as a conclusion, we have successfully designed and developed our device, which will be very useful for our further research. Thank you very much.
Thank you. Dobrochna Fritz, and next person Sebastian But.
Thank you very much. Good afternoon, ladies and gentlemen. My name is Dobrochna Fritz, and I'm a physical anthropologist. I'm doing my PhD in biomechatronics. And I'm going to present only a piece of my PhD studies that I'm doing on muscle asymmetries. So I'm working on not only lateral asymmetries, but also on antagonistic asymmetries that can be described as a muscle imbalance. So I'm working now currently on the topic of pelvis region, and it was already proven that muscles, that hip flexors present the scheme of shortening and hypertension, both in typical postural defects in the sagittal plane, as well as in low back pain. And I proposed, I guess, the exercise of resistance hip flexion in order to reduce this imbalance. So in my PhD, I created the device for training the resistance hip flexion, and it looks like that. It has also some strain gauges here in the foot bindings, and the load is applied up here on the frame, and due to the bindings, it's transferred to feet, and it's hard to raise the leg. That's the point of the equipment. So I was measuring the forces between the feet and the equipment during the exercise. As you can see, I performed some study with the BTS Smart system, so we were recording the kinematics. And we also put this in an antibody modeling system in order to model the forces and activity of the muscles. So we had 28 movement cycles of right and left side, respectively. And what we saw was that there was great activity of hip flexors during this exercise. So maybe it sounds trivial that the hip flexion resistance training activates the hip flexors, but it's not that simple, because it's important to evaluate the exercise in order to see how it works inside. So the most important result of this study is that the most active muscle is the psoas major. So this muscle is the most important in the aspect of muscle balance in the pelvic region, because it attaches to the spine in the lumbar region and then to the proximal head of the femur. So it's responsible for the compressive forces in the spine in the lumbar region. So I guess I will leave you with that conclusion, and I will just say that we are going to work more on that topic. Thank you very much.
Thank you. Sebastian But, and next Katarzyna Nowakowska-Lipiec.
Fellow researchers, my name is Sebastian But, and I stand before you to discuss a critical topic in the realm of forensic odontology, one that has 4 research implications for the justice system: the analysis of the bite marks. In the matter of the 150 seconds, I will take you on the journey through the challenges and the potential solution, the concept of the biometric dental receipt. Our aim of the study was clear: to dive deep into the integrated world of the bite mark analysis. We all acknowledge that the stakes are high when it comes to using bite marks as evidence in the court. Previous research has highlighted the need for more understanding of the 3D bite marks, as the 2D analysis 2D alone can lead to the false positives. It is imperative that our methods be firmly rooted in the scientific data and subject to rigorous court validation. Currently, bite mark analysis relies heavily on the quality, quantity, and the presence of the pattern features. Here, where our concept of the biometric dental receipts comes into play. This approach functions much like the principles of the golden triangle within facial recognition. It generates data consisting of the coordinates, material distances, and the proportions between the parts of triangles, all within fully 3D structures. This result captures the entire complex of 3D data, offering promising alternative to the traditional bite mark analysis methods. In our study, we conducted 144 matching trials examining dentitions in correlation with bite-in marks. The results were remarkable. Positive identifications of the individuals responsible for the bites were established, and also attempts to draw a parallels between the dentition of one individual and bite marks impression left by another one yielded negative outcomes. So, in conclusion, briefly, our findings suggest that the parameterization of the receipt could provide a viable solution to many of the challenges in the forensic medicine. Many of present here probably may recall the case of Mr. Tomasz Komenda, who spent 80 years in prison to the wrongful decision. Successful work on this biometric dental receipt in the future may prevent such twist of the fate. Thank you for your attention.
Thank you. Katarzyna Nowakowska-Lipiec, and next Grzegorz Gruszka.
Good afternoon, my name is Katarzyna Nowakowska-Lipiec, and I would like to present the study titled Assessment of Musculoskeletal Loads in 3 Types of Body Posture according to dolphins. So maintenance of upright posture is a complex process controlled by biomechanical and neurophysiological mechanisms, and postural disorders are visible changes in posture, and posture defects account for high percentage of health problems. And one of methods classifying the body posture is Dolphin's methods, and according to it we have 3 types of body posture: neutral, swayback, and lordotic posture. And the purpose of this study was to evaluate the effect of body posture according the dolphins on musculoskeletal loads. The study group consists of 29 subjects aged between 80 and 40 years, and assessment of body posture according to dolphins was carried out using a posture photographic assessment system. And furthermore, we measure some body parameters such as body segments, position in space, pelvic tilt angle, lumbosacral and thoracolumbar tilt, and for example upper kyphosis tilt angle. And the results obtained provided input for modeling body posture in any body modeling system. The whole body model was used, and each model has been scaled to subject height and weight. And the results and conclusions. So the highest value of resultant forces and compressive force component in lumbar spine were obtained in people with lordotic with swayback posture, and the highest value of shear force at L5S1 joint was obtained for people with lordotic posture, and the highest value of erector spinae muscle force also were obtained for the lordotic posture, and the highest force of transversus abdominis muscles for the swayback posture. Thank you.
Thank you. Grzegorz Gruszka, and next Hanna Zadoń.
Good day, everyone. My name is Grzegorz Gruszka. I'm a PhD student in biomedical engineering faculty. And I would like to discuss the influence of auditory stimuli on one's balance maintaining capabilities. In our work, we took 40 participants, and we wanted to check out whether a combination of auditory and visual stimuli actually affects the balance maintaining capabilities in a positive manner. So, as I've already stated, there were 40 participants, and every single one of them underwent 15 measurements, which were randomized between the patients. There were two visual environments, the real one and the virtual one. 3 auditory conditions, namely the uproar, which was basically a recording of a football stadium uproar, a white noise, which was created based on other publications, and silence. Participants were performing measurements in each of the auditory conditions with their eyes open, eyes closed, with a VR headset displaying darkness, static scenery, and an oscillating one. From our measurements, we can conclude that the affected, the analyzed values, which were the COP path length and the mediolateral asymmetry in an upright standing position, are not as heavily affected by auditory stimuli as they are by a visual one. Namely, we have concluded that both the auditory stimuli affect the COP path length, doesn't affect the mediolateral asymmetry coefficient. Therefore, there is a reason to believe that those stimulations can be used in order to affect the fall prevention in elderly people, although in healthy subjects the effect is not as noticeable or even omittable as it would be after reviewing literature and checking the effect of auditory stimuli for patients with impaired vision. Contrary to the visual stimuli, which affects the COP path length in a very significant manner, we can conclude that the visual feedback is way more important when it comes to maintaining upright posture and fall prevention and overall balance maintaining capabilities than, unfortunately, the auditory stimuli in healthy subjects. Thank you very much.
Thank you. Hanna Zadoń, and next person Marek Ples.
Ladies and gentlemen, dear chairman, my name is Hanna Zadoń, and I am PhD student in Department of Biomechatronics. And today I have a pleasure to present a work titled Numerical Simulation of the Musculoskeletal System during natural gait and walking with pulse. Walking with pulse is a form of physical activity involving fast walking, during which the upper limbs are also used to push off. And the correct technique is based on alternating and opposite movements of the limbs. This activity involves up to 90% of the muscles of the whole body. So the purpose of our study was to conduct numerical simulations to analyze the functioning of the musculoskeletal system during natural walking and walking with pulse. Numerical simulations were conducted in antibody modeling system. We prepare a model of natural gait and walking with pulse, and this model was based on experimental research. The analyzed movements were recorded using BTS Smart. This is a kind of a motion analysis system. And the numerical simulations allowed us to get information about the functioning both muscular and skeletal system. So we got information about the functioning of the in the lumbar region and muscle forces during natural walking and walking with pulse. Here we can see the results of our simulations, and walking with pulse affects the increase in loads occurring in the lumbar spine and in energy expenditure. Walking with pulse using the proper technique can positively affect the functioning of the human musculoskeletal system, and it has been shown that adding pulse to walking activates more muscles than during natural walking, which can also affect the burning of more calories. Thank you for attention.
Thank you. Marek Ples. And next person, Aleksandra Tusz.
I'd like to welcome you and apologize for absence of my colleague. Unfortunately, he fell ill after yesterday, so I'm here to replace him. This is mainly my colleague's experiment. I was assisting him in production of what can be read here. He was creating he was trying to come up with a simple method for creating an artificial muscle made with a nylon string. So, as you all know, production of artificial muscles is an expensive process, and it takes a very complicated technology to create. Also takes a long time. So my colleague tried to create an artificial muscle in a very economic and simple way. So he came up with an idea for using a polyamide, namely nylon, in order to create one. And he was successful. As you can see, all you need is presented in the pictures, so that's not much. It's a wolframic rod, it's a tungsten rod and a nylon string. He wanted to also make it work in conditions which are very similar to those of a human body. So first of all, he took the nylon string, he twisted it around around itself, then coiled it around the pen, heated it up to 60 degrees Celsius in order to achieve submelting point, the softening point of nylon. Locked it on the tungsten rod, let it rest and cool down, took out the rod, and as you can see, this is the coil he came up with. So the results are presented in figure 3. Contrary to what might be intuitive here, the figure 3A is when the muscle is contracted and when it's heated by a string that is coiled around the coil and covered with metallic silver. Applying electrical current allows the nylon string to contract, contrary to what intuitively would happen when we heat such a polymer, which would be actually its relaxation. When we take out the electric current, the heat dissipates from the silver-coated string, and then the nylon string actually becomes a bit elongated. As you can see, he also managed to count the functionality of his string, giving him a power density of 90 watts per kilogram, which is quite astonishing. This allows us to conclude that the process he came up with and the idea for the nylon fiber muscle is economical and actually allows for a quick and quite easy and cheap production of what can easily simulate a artificial muscle fiber. Thank you very much.
Thank you. Aleksandra Tuszy, and next Mirosław Czak.
Good afternoon, thank you for the introduction. Dear audience, when it comes to music, I'm almost sure that your music choices can differ. And it depends on your mood or the situation, or even time of the day. And we also wanted to analyze some features that can have an influence on music preferences. Because knowing how to choose proper music material for therapeutic purposes, especially in rehabilitation and for motor initiation, can be crucial for efficiency of this therapy. So such acoustic stimuli should be defined by the actual state of the patient. And the biopsychosocial model well describes factors, features from biological, psychological, and then, of course, social perspective, how it can affect our well-being at a specific moment. So we decided to bring this structure, this model, and use this for our purposes as a reference for our analysis. And as a result, we proposed a tool for collecting information about our patient regarding his first socioeconomic situation, then his music making history, and of course, finally, music preferences. What's more, we add some psychological methods of assessment for personality and emotions at a specific time. And now we need to validate this method and get the crucial informations so we can have a tool for therapist or a composer that helps bring our specific patient specific music material for therapy. Thank you.
Thank you. Mirosław Czak, and next person, Piotr Szaflik.
Mr. Chairman, ladies and gentlemen, my name is Mirosław Czak. I represent Faculty of Biomedical Engineering, Silesian University of Technology. Today I want to tell about the dynamic and static posture influenced by music entrainment. Sedentary life that becomes the domain today may result in abnormal posture. Minimizing physical exercise and lack of focus on posture causes irreversible health effects. Preventive recommendations include maintaining proper posture while sitting. Achieving the correct posture requires thoughtful action and concentration. However, it often happens that person engaged in other activity stops focusing enough on his posture. During this presentation, I would like to present a system to prevent this from happening. A system was developed by our interdisciplinary team, which includes both biomedical engineering specialists and physiotherapists, led by Professor Andrzej Midas from Faculty of Biomedical Engineering, Silesian University of Technology. The system is designed to stimulate attention to perform activities leading to correct body positioning. Corrective action requires the necessary muscle tension and appropriate positioning of body parts in accordance to physiotherapeutic recommendation, but adapted to the user capabilities. It requires two phases. A movement learning phase that uses feedback signals informing the user about the current results of motion actions. And second, developing an appropriate reflex initiated but easy accessible signals. The first task was solved using a camera in PC and software that compared images of activities with instructional video. And the second task was solved through a musical entrainment, which involves inducing a neuromotor reflex that can be associated with a specific task. During the learning phase, we also collect internal motion unit navigation data placed on the top of the head. The learning phase is combined with sonification of movement that is assigning individual sounds to specific phases corresponding to remembered movement patterns. The activities are repeated until the conditional reflex are consolidated. The exploitation phase involves the daily use of fixed personalized auditory signals repeated periodically at intervals determined by the physiotherapist and psychologist, but IMU on the top of head can also sense abnormal posture and trigger sonification cycle. It's important to design a stimuli to that the sonification effect is acceptable and not bothersome, so it should be done personally. The system meets the assumption, but requires further work to detecting spine movements because during tests we noticed that single IMU not always sense spine movements. Thank you for your attention.
Thank you. Piotr Szaflik. And next, Ewa Banachiewicz.
Good afternoon, my name is Piotr Szaflik and I'm a PhD student. Today I want to present my presentation with the title Effect of Metrorhythmic Stimulation on Modification of Walking with Pulse. And the aim of this study was to determine the effect of metrorhythmic stimulation on walking with sticks under the natural conditions. And in this study we involved 12 people with knowledge of correcting walking technique with sticks. For this research we used Xsense dot sensor and the RAS4Now application. The study consists of following steps. First step was a registration of physiological gait and determination of step frequency, and the next step was registration of gait with metrorhythmic stimulation at frequency corresponding to frequency of stepping. Second was 95% of stepping frequency, and the last one was 105% of the stepping frequency. And we examined 12 people, but for analysis we chose only 7 persons. And as we see on the first graph, 4 subjects adapted to metrorhythmic stimulation, and it was 11. It was the subject ID of the subject 3, 8, 11, and 22. And individuals who fit into the bits have lower values of gait variably, in particular 100%. Also for these people, the highest value of gait variably during metrorhythmic beats was obtained their frequency corresponding to 95% of the stepping frequency. And thank you for your attention.
Thank you. Ewa Banachiewicz, and next Dariusz Komorowski.
Hello, my name is Ewa Banachiewicz and I work in a nursing home as a music therapist. My patients are suffering from Parkinson's disease and dementia, and I would like to share with you one of my study. One of my patients took part in 5 music therapy sessions, and I was using RAS method. RAS method is the presentation of rhythmic auditory stimulation to facilitate movements and facilitate functional changes in patients with motor impairment. This is one of neurologic music therapy techniques. And my patient who suffers from Parkinson's disease took part in 5 sessions. Each session was consisted of 3 attempts. The first attempt was without any auditory stimuli. The second one was with only metronome clicks. And the third one was with more complex auditory stimuli, which was me playing the guitar. And in each attempt, I was counting the number of steps and time which needed to cover the distance. In every session, the distance was 5 or 10 meters, and it depended on her well-being. From this data, I calculated the cadence, velocity, and stride length. Cadence is number of steps per minute, velocity is meters per minute, and stride length is the distance between the heel strike of one foot to the heel strike of that same foot. And as you can see, for instance, on 26th of May, introducing more complex auditory stimuli causes that cadence decrease almost 6% on an average. In Parkinson's disease, it's very important to decrease number of steps. So I think I wanted to prove that more complex stimuli is more effective for Parkinson's disease and for RAS methods. But I know that it's only one case study, so we need more data to prove that. Thank you.
Thank you. Dariusz Komorowski. Barbara Mika, and next Maria Filipek.
Hello, everybody. My name is Barbara Mika, and I would like to present the presentation, the use of surface EMG to determine the muscle imbalance. Muscle imbalance can appear when the muscle of one side of the body is not so strong as those on the other side. This in particular visible for the persons or athletes who constantly use the same side of the body. Also, the muscle imbalance can indicate that something is wrong with the work of our muscle due to abnormal physical activity. So we pose the question, if the surface electromyography can deliver the reliable assessment of muscle imbalance based on maximum of muscle excitation. For finding the answer of the question, we develop the method of pre-processing of EMG signal. The pipeline of the method mainly consists of three steps. The first one is a set of filters, so we filtering the signal. After this, the envelope of the signal is determined, and the third step is thresholding. Using the variance analysis, the thresholding gives us the maximum of muscle excitation. We can see on the slide the exercises, the maximum voluntary contractions exercise, also the deep squat, which was investigated, the raw SEMG signal, and the maximum muscle excitation determined from SEMG signal marked as a horizontal red line. The results. We summarize the results in a table. The investigation was conducted for 8 persons. We obtained the SEMG signal for rectus femoris during the deep squat activity. And to validate our result, we simultaneously recording the SEMG signal and the force of the muscles. In the table, we have some parameters. We calculated the force of the ratio of the force of the right and left rectus femoris, and the percentage of maximum voluntary contraction for SEMG recorded during the deep squat. As we can see, the results are comparable, so it's mean that our method works correctly, and we defined the muscle imbalance as a difference between the percentage of MVC, so the muscle voluntary contraction. As conclusions, we can say the results are seems optimistic. So the answer to the posed question is yes, there are some possibility to determine, to estimate the muscle imbalance using surface electromyography. Thank you very much for your attention.
Thank you. Maria Filipek. And
Maria Hankus and Maria Filipek.
okay, together.
Good afternoon.
Good afternoon. Hello, everyone. My name is Maria Hankus, and with my friend
Maria Filipek.
We are students at the Faculty of Biomedical Engineering at the Silesian University of Technology. We are also members of a scientific club, Biokreatywni, based at the same faculty.
So today we would like to give you a short overview of our research regarding the shooting repeatability when shooting with short and long firearms using the MATLAB environment. So the study aimed to determine the radius of the smallest circle that cover all of the shots that hit the target, and on this basis to assess the repeatability of shots fired from short and long firearms.
So the study was conducted on a group of 20 people. We subdivided the group into professionals and amateurs. We defined professionals as a people who have undergone shooting training and shoot regularly, and defined amateurs as a people who have recreational contact with firearms.
Okay, so each participant fired 12 shots. The first 2 shots were test shots, and they were not taken into account during the analysis. But the series of the next 10 shots were analyzed in order to assess repeatability. And each time after 12 shots, the target was scanned and replaced. Next, we used the MATLAB environment to determine the smallest radius of the smallest circle that covered all of the shots that hit the target. And we also performed some statistical analysis of the obtained results. And on the right, you can see the result of our application.
So the study conducted that in the case of long firearms, the repeatability of fired shots depends on a shooter's experience, but in the case of the handguns, there is a lack of this relationship. We took some steps to find the reason why we had this obtained result. And the study also shown that in the case of the percentage of the shots fired that hit the target, depends on the shooter's experience in both cases. Thank you for your attention.
Thank you.
Thank you. Wojciech Pieniążek. And next person, Bruce Turner. The last one.
Dear audience, my name is Wojtek Pieniążek and I am student of the Biomedical Engineering Faculty at the Silesian University of Technology and a member of scientific club Biokreatywni, and I'm very honored to be able to tell you about our biomechanical research regarding the analysis of accelerations of selected body segments during long and short firearm shots. The research aimed to compare body movement when shooting between experienced and novice shooters. Następny slajd. A, tu jest. Przepraszam. Tu. Dziękuję. The group on which kinematics tests were carried out consisted of 20 people, including 18 men and 2 women, aged 18 to 50. The group was divided into 10 professionals who had regular contact with firearms and amateurs without experience with using firearm weapons. The subjects were equipped with Noraxon myomotion inertial sensors placed in crucial body segments such as hand, head, pelvis, and C7 and T12 vertebrae, which measured accelerations during shooting. Each shooter fired 10 shots from a long and 10 shots from a short firearm. Then, using MATLAB, the maximum accelerations of key body segments at the moment of firing the shot were calculated. The research results indicate large difference in acceleration between professionals and amateurs, both when shooting with short and long weapons. The highest accelerations values for both research groups were recorded by sensors placed on the hands, Furthermore, research shows that during the short firearm shot, the left hand of professionals accelerates much faster than that of amateurs, while the C7 and T12 vertebrae are much more stable. This result may be due to the weak grip of inexperienced shooters, which results in less compensations of recoil by the left hand. In the case of long guns, inertial sensors recorded higher accelerations in professionals in the head, vertebrae, and pelvis, and lower accelerations in both hands. The reason for this may be the experience of advanced shooters in counter-reacting the recoil by firmly pressing the stock of the weapon to the shoulder, as a result of which a large part of the energy of the shot is transferred to the shooter's torso. Amateurs, on the other hand, focus on the strong hand grip and not on transferring the recoil to the arm and to the torso. Thank you for your attention.
Thank you. And Bruce Turner, the last person.
The mapping sonification for the pelvis in gait, and this is for the purpose of developing symmetrical gait behaviours, mostly considering for physiotherapeutic practice, but to improve movement performance and to influence behaviours. There's some good research from Dubris and Brezin, who've conducted a meta-review of all kinds of different applications, who've taken or sonified data from one dimension and converted that into the auditory dimension. And these are really ranked according to which is most successful. And in really summary, that on the horizontal plane, it's quite useful to use spatialization dimensions. It's logical because our echolocation can recognize placement of where sounds happen, and also using the vertical plane, using some sort of sense of high and low, which relates to pitch. So here's some instruments that I've made that really just take the data from this movement and use that data converted into MIDI, and I've applied it to various aspects. So it's quite sort of practice-based research, which really means that we just try things and see what works, and it's really to make it seem musical. This first example is quite musical. Although quite removed from the original curves. In this instance, it's just taking pitch information, but it seems a bit kind of crazy and a little bit too scattered. So even though it's quite successful, it's a little bit confusing. And we got this using a continuous bass note. But that's actually very good because you can really chart the kind of parameter when the high-pass filter opens out. And so that's, I think, one of the better examples of that. Another example there. But also I'm going to play you this slightly different instrumentation, which is taking the peaks and the valleys of every single axis. You're able to assign this to a MIDI note, which then triggers a sample. And so we're basically making a drum machine out of the pelvis movement. This one here is actually a Roland 808 classic electronic sound. But the lilt or the swing sounds a little bit strange, and it seems to lend itself better to this kit, which is using a Cuban percussion kit. So this is perhaps the most successful out of all of these experiments. Well, what's going to happen with this next is it's going to be tested on participants in practice.
Thank you.
Talking today about parameter mapping.
Okay, so it was the last person. So we would like to thanks for each speakers. Congratulations. We are impressed. We hope so that the research will be the same high level for here. And the best, we must choose the best presentation. So the announce of the best presentation will be a close of the ceremony of the conference. So thank you for one more time. Thank you for your attention, and we would like to invite for the lunch. Okay, thank you.